The objective of this lesson is to discuss equivalent ratios by modeling and calculating equivalent ratios. In previous lessons, students solved ratio problems using tape diagrams and double number lines. In this lesson, students will model ratios on graph paper, creating ramps, and use the models they create to discuss equivalent ratios. What do we know about ramps? We see them when exiting or entering the freeway. We see handicap ramps outside buildings for individuals in wheelchairs. What makes a ramp or parts of one? They have a base, a height, and an inclined plane. Which part of the ramp has steepness? The inclined plane of the ramp has steepness, like a hill or stairs. If this ramp has a base of 4 centimeters and the height is 2 centimeters, we could say our ramp has a base to height ratio of 4 to 2. What would be another ramp that is equivalent to this one? If we double the length of the base, what would the height be? If we doubled the base to be 8, then we would double the height, which would be 4. If we draw this ramp and compare it to the first one, are they equivalent? Yes, it looks like the steepness of the inclined plane of the two ramps are the same. What if we find 1/2 of the length of the base? What would the height be? If the base is 1/2 of 4, that would be 2, and the height would be 1/2 of 2, which is 1. If we draw this ramp and compare it to our other ramps, are they equivalent? It looks like the steepness of all the ramps are the same. There are several ways equivalent ramps could be created. One way is thinking of a ratio as a composed unit. Another way is by iterating. In the image, the ramp was created by iterating the ramp 2 times. The ramp has a ratio of 8 to 4. Partitioning is another way to create an equivalent ramp. The ramp in the image was created by partitioning the original ratio into a smaller ramp. This ramp has a ratio of 2 to 1. Equivalent ramps or ratios can be made through a combination of partitioning and iterations. The ramp in this example was created by partitioning the original ratio of 4 to 2 into a smaller ramp of 1 to 1/2. The original ramp's base length and height were partitioned into 4 pieces to create a ramp with a base length of 1. The ratio of this ramp is 1 to 1/2. This ramp was then iterated or copied 5 times. This new ramp has a ratio of 5 to 2 1/2. Another perspective for creating equivalent ramps or ratios is thinking of a ratio as a fixed number of parts. A ramp can be created by looking at the multiplicative comparison between the base and the height of the ramp. It is similar to using a tape diagram. The original length of the base was 2 times as long as the height. Likewise, the height is 1/2 as long as the base. Different ramps can be made by changing the value in each fixed part. Here, the ratio is 4 to 2. If each part is 3, then the equivalent ratio could be found by multiplying 4 times 3 for the length of the base and 2 times 3 for the height. The equivalent ramp would have a base length of 12 and a height of 6. If each part is 1/2, then the equivalent ratio could be found by multiplying 4 times 1/2 for the length of the base and 2 times 1/2 for the height. The equivalent ramp would have a base length of 2 and height of 1. 2 additional strategies for finding equivalent ramps or ratios is additively related or multiplicatively related. Additively, ramps can be created by repeated addition by iterating multiple ramps to create ramps with the same steepness. To create a ramp with a length of 12 and a height of 6, 3 copies of the ramp were added together. This can then be solved with repeated addition. 2 plus 2 plus 2 equals 6, and 4 plus 4 plus 4 equals 12. Multiplicatively, equivalent ramps or ratios can be created by scaling or multiplying. A ramp could be made to be 3 times as large by multiplying the height and length of the original ramp by 3. We could multiply the length by 3, or 3 times 4 equals 12, and the height by 3, or 3 times 2 equals 6. Students will continue to create a variety of ramps using equivalent ratios, making larger ones and smaller ones, and comparing them. The objective of this lesson was to discuss equivalent ratios by modeling and calculating equivalent ratios. We met this objective by having students model equivalent ramps using equivalent ratios. Students learned different strategies for creating larger and smaller ramps by iterating or partitioning ratios and using tape diagrams.